everyone, welcome back to MATLAB. Now let us start the next exercise, the final exercise of trigonometry, which is exercise 11.4. Here is the first question. Evaluate the following. First section, first one. Here is the question: 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Let us solve the problem. So we know that tan theta equal to sin theta by cos theta, and secant theta equals to 1 by cos theta, and cot theta equal to cos theta by sin theta, and cosecant theta equal to 1 by sin theta. So here are the tan theta values which we can change into sin and cos. So let us substitute them. 1 plus what is tan theta? Sin theta divided by cos theta, plus what is secant theta? 1 by cos theta into 1 plus what is cot theta? Cos theta divided by sin theta minus what is cosecant theta? 1 by sin theta. Now here the denominator is same for both the values. This becomes 1 plus cos theta at the top, sin theta, and the middle term is plus, so plus 1 into 1 plus, here the sin theta is same, so sin theta, the top value is cos theta, here the symbol is minus, minus 1. Now cos theta is multiplied with 1, so cos theta into 1, making cos theta as denominator for the whole equation. Cos theta into 1 is cos theta plus sin theta plus 1 divided by cos theta. Sin theta into 1 is sin theta plus cos theta minus 1 divided by sin theta. So this would be the next value. Here you can see clearly cos theta plus sin theta as one term and remaining value 1 as one term. So assume let us assume a equals to sin theta plus cos theta, a equals to sin theta plus cos theta, or cos theta plus sin theta, both are same. So let us assume sin theta plus cos theta as a, and the value other value b, the other value 1 as b. So b equals to 1. So the whole equation appears like a plus b, cos theta plus sin theta is a and 1 is b. So a plus b into your sin theta plus cos theta is a and the one value is b. So minus b. So we know that a plus b into a minus b is a square minus b square. So this becomes, what is a here? Cos theta plus sin theta, or sin theta plus cos theta. It's up to you. Whole square minus what is b here? B is 1. So 1 whole square divided by here cos theta into sin theta. Cos theta into sin theta. Now we know that a plus b whole square, formula for a plus b whole square is a square plus b square plus 2ab. Now let us substitute them. A is cos square theta and b is sin square theta plus 2, what is a? Cos theta, and what is b? Sin theta. A plus b whole square, a square plus b square plus 2 into a into b minus 1 whole square is 1 divided by cos theta into sin theta. We know that from identity 1, sin square theta plus cos square theta equals to 1. Sin square theta plus cos square theta equals to 1. So now this becomes, what is the value of cos square theta plus sin square theta? It is 1. 1 plus 2 cos theta sin theta minus 1 divided by cos theta into sin theta. Plus 1 minus 1 gets cancelled. Now we are left with, what is the value here that you are left with? 2 cos theta into sin theta divided by cos theta into sin theta. Both cos theta sin theta gets cancelled. Now we are left with 2. So this is the answer for 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. So this is the first one. Now let us solve the second question, which is given as sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Let us solve the problem here. If you want to split completely, you can split it, or else you can just assume them like this. Like consider A as sin theta and B as cos theta. Now here you can write it as A plus B whole square. A is sin theta, B is cos theta, A plus B whole square plus what is sin theta here? A minus B whole square. If you write the expansions of this, you will get A plus B whole square as A square plus B square plus 2AB plus what is A minus B whole square? A square plus B square minus 2AB. You can see plus 2AB minus 2AB both gets cancelled. Now you are left with A square plus A square. What is A square plus A square? 2A square. And B square plus B square. What is B square plus B square? 2B square. So you can write them in this way directly. So what is 2 into what is A square? What is the value of A here? Here it is sin theta. So sin theta whole square plus 2 into what is B here? B is cos theta. So B into cos theta whole square. So this becomes 2 into sin theta whole square is 2 sin square theta plus 2 into cos square theta is 2 cos square theta. So here you can common out both the 2's. If you common out 2, you are left with 2 into sin square theta plus cos square theta. We know that from identity 1, sin square theta plus cos square theta is 1. Now when you substitute here, 2 into 1 is 2. So this is the problem. And if you want to do it by all the steps, then you can simplify them. This is one method, and you can do in a different method. Most likely the school method would be this. So here we will expand them. The question was sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Here we substitute everything. This is A plus B whole square. So A square plus B square plus 2AB. What is A? Sin theta, and what is B? Cos theta. Here plus A minus B whole square. A square plus what is B? Cos theta whole square minus 2 sin theta cos theta. So plus minus 2 sin theta cos theta and plus 2 sin theta cos theta gets cancelled. Now we know that sin square theta plus cos square theta value is 1, and sin square theta plus cos square theta value is 1. And in between you have the symbol as plus. So you write 1 plus 1 is 2. So either you can use this method, or else you can just solve with this method. It's up to you. You can use any one method to solve the problem. So that is the second problem. Now let us shift to the third one. Here the third question is secant square theta minus 1 into cosecant square theta minus 1. You have the identities. If you want to write them, you can directly write them. Let me help you out in writing the identities. We know that the second identity is secant square theta minus tan square theta equals to 1. From here, you can write this as, if you shift the tan square theta to the other side, that becomes secant square theta equal to 1 plus tan square theta. So when we shift the plus 1 to the other side, this becomes secant square theta minus 1 equals to tan square theta. And we know the third identity is cosecant square theta minus cot square theta equals to 1. When you shift to the other side, this becomes cosecant square theta equals to 1 plus cot square theta. Now I'm shifting the 1 to this side. This becomes cosecant square theta. When plus 1 shifts to the other side, this becomes minus 1 equals to cot square theta. So from here, we can clearly see that secant square theta minus 1, the value for secant square theta minus 1 is tan square theta, and for secant square theta minus 1, the value of cosecant square theta minus 1 is cot square theta. You can directly substitute them. What is secant square theta minus 1? Tan square theta, and into what is cosecant square theta minus 1? It is cot square theta. And by the way, we know that cot theta equal to 1 by tan theta. Cot theta equal to 1 by tan theta. Here you can substitute them. Tan square theta into what is cot? 1 by tan square theta. Both tan square theta gets cancelled. Now you're left with 1. So this is the third problem. So this is the first section. Now let us shift to the second section. I hope you are clear in that. Now let us start the second problem of the final exercise. Second question. Show that cosecant theta minus cot theta whole square equal to 1 minus cos theta divided by 1 plus cos theta. So show that cosecant theta minus cot theta whole square equal to 1 minus cos theta divided by 1 plus cos theta. This is the one which is asked us to prove. So let me take the LHS part. So the LHS part is cosecant theta minus cot theta whole square. So now let me write them in the different way. We know that cosecant theta equal to 1 by sin theta and cot theta equals to cos theta divided by sin theta. Cos theta divided by sin theta. Now we can write cosecant theta as 1 by sin theta minus what is cot theta? Cos theta divided by sin theta whole square. So here the denominator is same. So it is sin theta. At the top you can write it as 1 minus cos theta whole square. Now you can split them. So this becomes 1 minus cos theta whole square divided by sin square theta. So we know that from identity 1, sin square theta plus cos square theta equals to 1. So this becomes from here, if you want to know the value of sin square theta, you will shift the other term to the other side. This becomes sin square theta equal to 1 minus cos square theta. Now you can write 1 minus cos theta whole square divided by, you can write sin square theta as 1 minus cos square theta. So you can write 1 as 1 whole square. Even 1 square value is 1. You can write the 1 as 1 whole square. From here you can see that a square minus b square. So here the a square is 1 whole square minus the b is cos theta. So cos theta whole square. 1 square minus cos theta whole square. So a square minus b square value is a plus b into a minus b. Now you can substitute at the bottom. So 1 minus cos theta whole square divided by, here you can write these terms a square minus b square as a plus b into a minus b. What is a? 1 plus what is b? Cos theta into a minus b. A is 1 minus b is cos theta. 1 minus cos theta. So 1 minus cos theta and 1 minus cos theta gets cancelled. Now you are finally left with, so here you are left with at the top is 1 minus cos theta divided by, and at the bottom you are left with 1 plus 1 plus cos theta. So this equals to RHS. And at the top he has asked us to prove the same thing. Let me show you. So he has asked us to prove that cosecant theta minus cot theta whole square equal to 1 minus cos theta divided by 1 plus cos theta. So you have taken the LHS and you have solved the problem to the last step, which concludes as 1 minus cos theta divided by 1 plus cos theta, which is RHS part. So therefore LHS equals to RHS, which is cosecant theta minus cot theta whole square equals to 1 minus cos theta divided by 1 plus cos theta. So this is the second problem. Now let us discuss the third one. So here is the third question. Sorry, here is the third question. Show that square root of 1 plus sin A divided by 1 minus sin A equal to secant A plus tan secant A plus tan A, and the given condition is 0 degrees less than 90 theta less than 90 degrees. So the value has to be greater than 0 degrees but should be less than 90 degrees. So it has to be between, the theta value has to be 30 degrees, 45 degrees and 60 degrees. So the values here in this condition, the angle should be between 30, 45, 60 and not 0 and not 90. So let us solve this. Let me take LHS. The LHS is 1 plus sin A divided by 1 minus sin A. So we use one thing, we called it as rationalization. Rationalizing the denominator. What is the denominator value is 1 minus sin A. Rationalizing 1 minus sin A is 1 plus sin A. So few call them as rationalizing factor. So the factor for 1 minus sin A would be 1 plus sin A. If we would have taken 1 plus sin A, then rationalization factor would be 1 minus. So the symbol gets changes. That's it. So if you take RF, we call in shortcut as R dot F. So the RF of the denominator, which is 1 minus sin A. So the sign gets changes, it becomes 1 plus sin A. Now you can write them as 1 plus sin A divided by 1 minus sine A. You can write them here. Multiply it on both numerator and denominator. So we will multiply it both numerator and denominator. So 1 plus sine A divided by 1 plus sine A. 1 plus sine A divided by 1 plus sine A. Now let us multiply them. Square root of 1 plus sine A into 1 plus sine A divided by denominators 1 minus sine A into 1 plus sine A. Here you can see, let us assume A equals to 1 and B equals to sine A. So the numerator part becomes, you can write as A is 1 plus B into the other one, A plus B, which becomes A plus B into A plus B, A plus B whole square. And now the denominator part, 1 is A minus sine A is B into 1 plus, which is A plus sine A is B. A minus B into A plus B, which is A square minus B square. Now let us substitute them. So square root of 1 plus sine A whole square divided by 1 whole square minus sine square A. So now we are separating the root to numerator and the denominator. Now we can write it as 1 plus sine A whole square divided by root of 1 square is 1 minus 1 minus sine square A. There you can see both square and square root gets cancelled, and we know that sine square A plus cos square A equals to 1. From here, if you shift the sine square to the other side, this becomes cos square A equals to 1 minus sine square A. Now 1 plus, after square root gets cancelled, we are left with 1 plus sine A divided by, what is 1 minus sine square A? 1 minus sine square A is cos square A. So square root of cos square A. Both square and square root gets cancelled. Now we are 1 plus sine A divided by cos A. Now we are splitting them. You can write it as 1 by cos A plus sine A divided by cos A. Now we are left with 1 by cos A. 1 by cos A is secant A plus sine A divided by cos A, which is tan A. And this is the RHS part. So in the problem, he has asked us to prove that root of 1 plus sine A divided by 1 minus sine A is equal to secant A plus tan A. So this is the problem. So therefore, LHS equals to RHS square root of 1 plus sine A divided by 1 minus sine A equals to secant A plus tan A. This is the problem. So now let us shift to the fourth question. So that 1 minus tan square A divided by cot square A minus 1. So he's asking us to show that 1 minus tan square A divided by cot square A minus 1 equals to tan square A, and the condition is 0 degrees less than theta less than 90 degrees. This means that theta will be equal to 30, 45 and 60. Theta is not equal to 0 or 90 degrees. So this is the meaning of this condition. Now let us prove it. LHS 1 minus tan square A divided by cot square A minus 1. So we know that cot A equal to 1 by tan A. Cot A equal to 1 by tan A. So we can write it as 1 minus tan square A divided by, we can write cot as 1 by tan square A. 1 by tan square A minus 1. Here you can see we multiply tan square A into 1. So 1 minus tan square A divided by 1 minus tan square A into 1, tan square A. Tan square A into 1 is tan square A divided by, what is left, tan square A. So both 1 minus tan square A 1 minus tan square A gets cancelled. Now you are left with 1 divided by 1 by tan square A. So the denominator shifts, it becomes numerator. So now you can write tan square A. So anything into 1 is the same answer. So tan square A into 1 becomes tan square A. That is the RHS part. So therefore 1 minus tan square A divided by cot square A minus 1 equal to tan square A. LHS equals to RHS. So this is the problem. Now let us shift to the next one. The fifth problem. So show that 1 by cos theta minus cos theta equals to tan theta into sin theta. 1 by cos theta minus cos theta equals to tan theta into sin theta, where 0 degrees less than theta less than 90 degrees. So here is the LHS part. So 1 by cos theta minus cos theta. So cos theta into cos theta. We multiply these things to make one numerator. One numerator is cos theta. So here cos theta into cos theta. 1 minus cos theta into cos theta is cos square theta. And we know that from identity 1, sin square theta plus cos square theta equals to 1. Here from here, if you shift the cos square theta to the other side, that becomes sin square theta equal to 1 minus cos square theta. So what is 1 minus cos square theta here? It is sin square theta. So sin square theta divided by cos theta. So now I am writing the sin square theta as sin theta into sin theta divided by cos theta. Sin square theta as sin theta into sin theta divided by cos theta. So now you can write it as sin theta divided by cos theta into sin theta. What is sin theta by cos theta? Tan theta. Tan theta into sin theta, which is RHS. So therefore, LHS equals to RHS, and the condition was 1 by cos theta minus cos theta equals to tan theta into sin. I hope you are clear in these 5 problems, and if you have any doubts, you can comment in the comment section. Thank you. Have a great day, and please do like, share, and subscribe.